So in my last video I tried to test out 4 different gyros, but apparently only 2 out of 4 gyros was working with my specific servo. So today what we will do, we will try to figure out can we make those 2 non-working gyros still work with my specific servo, and if not, then what is the reason why. So first of all, we will start with some theory. We will try to understand how things are actually working, how they interact with each other, what's important, what is not important, and then once we learn some theory, we will switch actually to the practical tests where we will test out our theory to make sure that we understood everything correctly and it's working exactly that way, okay? Now, after watching this video, I can promise you one, that you will know all ins and outs where it's coming to steering electrical components, so you do not make mistakes like I did in my previous video. So keep watching and let's get to the theory. So let's start from the beginning and let's take a look what steering components are actually involved in drift car steering, and then we will go from there. So first of all will be your servo, of course, then it's gonna be your gyro, and the last component is your radio system. So all those 3 components are needed to control your steering for your drift car. Now let's take a look what is analog system and what is digital system and what is important here and which components are involved in this case. So of course it's gonna again starts with your servo, then it's gonna be your gyro, but those are not only 2 components which are responsible for digital or analog system in your RC car. Your radio system as well is important, okay? So all those 3 components you need to pay attention when you are configuring your drift car, either you are going with analog or digital signal, they all are important. Now let's take a look actually how it matters where it's coming to the sequence itself. So the way it works is that it actually everything starts with your radio system, okay? So that's important. Then it's gonna be sent to your gyro, which is sitting in the middle, and the last component which will be in this chain is your servo. Okay, so that's how it's pretty much working, starting from your radio system and ends with your servo. Now let's take a look on how the actual digital and analog system is working. So it uses PWM frequency, which stands for pulse width modulation, and it is used to control the servo position. Okay, so now if you are asking what is difference between analog and digital system, so starting with analog system, it will be working in 50 Hz frequency, and the pulse sent to your servo in this case will be happening every 20 milliseconds. So if I convert those 20 milliseconds in seconds, it's gonna be 0.02 seconds. That's how quickly analog system is updating position for your servo where it needs to be, okay? Now, if we will compare this now with digital system, then digital system is actually high frequency system which works in 333 Hz. So you can see it's almost 7 times quicker than analog system, and pulses has been sent every 3 milliseconds. So that will be equal 0.003 seconds, okay? So if we are now looking on this timing, can you really feel the difference between 0.02 and 0.003 seconds? Well, somebody probably cannot really feel the difference, but there are some who say that they feel the difference, okay? So if the digital system's out there with high frequency, then most likely it does matter, and that is why it's kind of important. What else is important for the pulse width is that it has been used as well where it's coming to microseconds. That's how the position of your servo is happening. So when you are looking, for example, for the gyro specification, you sometimes might notice that it stands that neutral position is 1500 microseconds. So what does this mean is that sometimes somebody, probably you hear around that complaining that they put it in gyro and something strange is happening. And that reason could be if you have set your gyro in a car, you had electronically adjusted your center position of your servo. And now that digit is not sitting at 1500, but it's somewhere off. That can now conflict with your gyro, which is looking for center position, and it has to be like 1500 in majority situations, those microseconds. So what is the fix here? The fix is that you need to set the servo in your car, reset it to neutral position, reset all the endpoints which you had set in your radio system, also recenter the position for the servo, and then adjust your center position for your servo from the technical perspective on your car. So that you will be doing with the horn and your steering arm connector. Okay, that should be centered, and from there, when it's centered perfectly, you will just go in your radio system, set your endpoints, and it's gonna be good to go. Okay, so those microseconds are important, because how servo is working, it's working in a range with those microseconds, and 1500 microseconds is that center position. So if you're digitally adjusting it off, you might have problems. Okay. Now, so that was important about the signals and refresh rates. Now let's take a look on the next slide, which will be talking about gyro input. So all 4 gyros, which I has been using in my previous tests, will be able to accept refresh rates from 50 till 333 Hz. So when we are talking about 50 and 333 Hz, kind of analog and digital systems, those are just like the hertz can be off a little bit for the digital system, because there is even much higher hertz digital systems as well, and analog system as well can work at higher refresh rate than 50. Those are just standards which are kind of taken in these days, in account. So normally when we are talking about 50 Hz, that will be equal as analog system, and 333 Hz will be our digital system. Okay, so all 4 gyros which I was testing, they all are able to accept 50 and 333 Hz. There is also worth to note out that digital systems which are working in 333 Hz, they always will be capable accept lower frequency, which in this case is 50 Hz. Okay, or anything in between as well. So that's worth to know that. Now, gyro outputs at the same time is different story, where it's coming to all my 4 gyros which I was testing. So let's do that. Let's remove my video so we have full screen here and we can see actually what I'm sharing. So let's start with MST MGX gyro. In my previous video I showed you that there are actually 2 MST MGX gyros on the market. Okay, so don't get confused. So this one specifically, which you can see here and which I was testing, is older version, and then there is newer version, and they have one big difference which I was speaking in my previous video, and the difference was that this specific gyro has manual mode, where I can select, do I want to use analog mode or do I want to use digital mode? And that is why this gyro can work either in 50 Hz frequency or 333 Hz frequency. Of course, if you will be using a high-speed digital system, in your setup, then of course you will set it to digital mode, but if you will be using analog mode, then you will be using 50 Hz. Now, if we will be looking at the next gyro, which I was testing, AGFRC gyro, this has something new, which is follow mode. Now let me read what the follow mode stands for. So while gyro input is within 50 till up to 100 Hz, the servo output on the gyro is the same as input frequency. So you see, if your radio system works in a range from 50 till 100 Hz, which most likely will be analog radio system, your gyro will automatically be using as well analog system, and automatically will be working only in 50 Hz. Now, if you will be using a radio system which is high frequency system, digital system, then it's gonna be over most likely 100 Hz, and gyro automatically will be switching to digital mode and using 333 Hz. Okay, so this gyro will be exactly as the another MST MGX gyro, which is the newest one they are offering currently, which has a little bit different shape from the one you are seeing here. that will be pretty much using as well this follow mode, okay, and working that way. Now, the next gyro, OMG version 3, which I had, and I had issues with it, it has only output with 333 Hz. Same applies as well for Yokomo version 4, it has only 333 Hz output. What does this mean in this situation? It means that those two gyros, if you are planning to get yourself and you are still using analog servo, don't do that because they will burn it down. Okay, so those two gyros, as you can see, only work in a high frequency, which means they are digital gyros and they won't be able to work with 50 Hz refresh rate. So now what's happening in this situation if we are using analog servo which can accept only 50 Hz and we will be now pushing in 330 Hz high frequency refresh rate, is that it will simply burn it down. It will be buzzing, it's not gonna work properly, and it will simply overheat very quickly and burn it down. Okay, so never use analog servo if you are using any of those two digital gyros. Okay, so now let's take a look on the next slide, which is talking about the servos which I tested. So I was using MST SC0352 digital servo. So why the heck those two gyros, which are pushing out 333 Hz, was not working with my MST gyro, which is digital and it's made by Servos? And the answer is that according to Servos website, this digital gyro can work only up to 240 Hz frequency. So how it can be that digital gyro is not able to work with 333 Hz? The answer is pretty much simple here. It's because this is older generation servo, and back in the days this range from around 200 Hz till 250 Hz was counting as a high frequency gyros, servos, and that is why this was maxed out only at 240 Hz. And that is why I had issues with my system, with the setup, that those two gyros was not working. Okay, so what was happening, this gyro, this servo was accepting only maximum 240 Hz, but I was trying to push in 333 Hz refresh rate, which is around almost 100 Hz more than this can handle. And that is why I had issues, that it was buzzing, it was not working properly, and it was very quickly heating up. Okay, so if you are looking for the servo, pay attention to this number because this is important. So what I can tell you right away is that in these days, those are the standards. 50 Hz for analog systems, 333 Hz. Most of the digital gyros in these days will be using 333 Hz, okay? So that's something as well which comes down actually to the manufacturers of gyros, manufacturers of servos. They do not provide this important information. And that is why many people are making mistakes, because you simply cannot find this information, what type of frequency they are using. And as you can see, it's very important. Okay, now let's go to the next slide and actually let's take a look how and which setups will be working, which are worst to consider and avoid, and which won't work at all. Okay, so let's start with MST and AGF-RC gyro. So first of all, I had my radio system, which was analog radio system, which was working in a 50 Hz. Then I was using either MST or AGF-RC gyro, which was receiving 50 Hz from my analog radio system and sending 50 Hz to the servo, which was my MST digital servo, and that was receiving only 50 Hz. So as I told you already, digital servos can fall back to lower frequencies and work just fine without any issues, any of them, not only this specific one. So this was capping out at 240 Hz, but just because I was using only 50 Hz kind of refresh rates, as you can see in this case, both of those gyros, MST and AGFRC, was working fine in my setup and I didn't have any issues. Okay. Now let's take a look on another example. So OMG and Yokomo gyro. If I will be using my analog radio system and that will be sending 50 Hz to my gyro, which will be receiving 50 Hz, but now remember that OMG and Yokomo gyros, they both was outputting only high frequency digital signal, so they were able to receive from 50 till 333, but outputs only 333 Hz digital signal, and that was sent to my servo, which was MST digital servo, which was maxing out at 240 Hz, and that is why it was failing. So what I was trying to do here is push those 333 Hz in my 240 Hz digital servo, and that is why it was not working. Okay, so if you will try to set up system like this and try to use OMG version 3 or Yokomo version 4 gyro, it's not gonna work. Okay, now let's take a look on another example. So OMG and Yokomo gyro, if I will be using analog radio system, and that will be pushing of course 50 Hz to my gyro, receiving them and sending out again digital signal, which is 333 Hz. And now if I will be using servo, which is for example RFD RSST digital servo, that will be now receiving 333 Hz. Now again, no RevD or Yokomo displaying their servo refresh rates. There is no official information about that one, but we can assume that they are fairly new servos on the market and that they are working actually with 333 Hz refresh rate. We can also assume this because people are using this kind of setup and it works fine. Okay, so keep that in mind. Like I said, 333 Hz is just a standard. There can be always situation, you know, that your maybe servo is actually working up to 300 Hz only. I'm not saying that it is, but it could be. So what would happen in this situation? It still would work, but in a long term it won't be a good solution, because in the long term your servo still can die because it's still receiving higher frequency than it's supposed to accept. Okay. So this is important that you get this information out, what frequency servo is you are using. Now if we are looking on this specific setup, so my analog radio system will be working just fine with OMG and Yokomo gyros in this situation, if I will be using as well fully digital servo, which can accept 333 Hz. Now this same setup, if I will be using for example MST MGX radio system, which I can manually now switch as well of course to digital signal, that will look exactly the same as well. I still can use my analog radio system, I can switch my MST MGX gyro to digital mode, and it will be working fine with the RevD RSST digital servo, okay, in digital mode. Now when it's coming to AGFRC and MGX, the newest and latest version, their situation is a little bit different. You won't be able with those two gyros achieve this, and the reason is why, because your analog radio is sending 50 Hz, and remember those two gyros, they have follow mode, which means that they are reading signal from your radio system, and instead of sending 333 Hz from the gyro, it will be sending only 50 Hz. So if you will go with AGFRC version 3 or the latest MST MGX gyro, your system, even with RevD RSST digital servo, still will be working only in 50 Hz. So setup still will be working just fine, but you are pretty much missing out of the digital servo high frequency kind of benefits. Okay, now let's take a look on one more option. So now again OMG or Yokomo gyro, but in this case we will be using now fully digital radio system, which can work up to 333 Hz. Okay, Now, if that is sending now 330 Hertz to our gyro, and then that sends forward again 330 Hertz to our RevD digital servo, it will be receiving as well 333 Hertz, and this will be the best option you can get where it's coming to digital system. So your radio system is digital and working a high frequency, your gyro is working in a high frequency, and your servo as well is working in a high frequency. So this is the best option you can get, okay? Now, every single gyro which we were testing, they all will be able to work in this setup, okay? So, including as well AGFRC, which has this follow mode, and the latest MST-MGX gyro, which have this follow mode, because now our radio system is sending signal which is over 100 Hertz, which means the gyro automatically switches to digital mode, and we are now sending as well digital signal, of course, to the servo. Okay, so this is best case scenario. Now, answering the question, do you really need to go for this kind of high frequency digital setup for your drift car? My answer would be something like this. So if you are in a hobby just for fun, maybe you are just drifting, in a couple of weekends through the year, or in your, front yard or whatever it's gonna be, then don't spend money on things which probably not gonna benefit you so much, because you still probably will enjoy your drift car on a budget, and everything still will be working fine as well with the analog system, okay? Now, of course, if you are looking for the best of the best, the money is not the problem, and maybe even you are looking to participate in competitions and looking for those higher positions, then of course go for it. Having a fully digital high frequency system always will just benefit you, but keep in mind as well that would be, the same as you can buy the best camera on the market, but it does not mean that you will accidentally become, a best photographer or even a good photographer, because all those expensive cameras has all the ins and outs you would need to know, functionality which you need to understand, and if you do not understand that, then you probably can actually get worse results out of your high performing system than if you will just go, with basic analog system. So keep that in mind, okay? Now, with all that being said, now you know the reasons and theory what went wrong in my previous test video, why 2 of the gyros was not working, and now answering the question, can I make those 2 gyros work with my specific MST digital gyro? The answer is big fat no, okay? Now, to test this theory as well in real life, what we will be doing, I will take out my goodies, and we will actually set up a workbench, and we will try out now this in actual practice and see if the theory actually works, what I showed you now in a real life. Okay, so before we get to the practical tests, let's take a look on the radio systems. So I have 4 different radio systems here. One common thing, they all have screens. So this is something I'm looking for when I'm buying a radio system, because I want to have a screen so I can actually see, the digits and everything adjusting, because that will have much better precision than trying to, listen to beeps, counting turns or whatever it's gonna be, So display is a must. Now this one specifically is FlySky FSGT3C radio system. This is only one controller here, which is sending out analog signal to the servo output. Don't get confused that it says here digital, okay? So it's not digitally sending out high frequency signal to your servo. It's still 50 Hertz radio system. And yeah, so now why I like this controller here is that it feels very, very good in my hands. It has also rechargeable battery inside in it. So that's a very, very good plus, because you do not need to worry about the batteries and all that stuff. So it can also hold up to 10 different models, and the receivers for this specific radio system you can buy from AliExpress for, I don't know, like $10 or even less, Now, next one, we have another FlySky controller. So this is, if I'm not mistaken, FSG11P model, fairly new on the market. So the rest of the three controllers here, you can see they all have colorful displays. So I'm confident enough to say that in these days, when you are buying a radio system with colorful display, it most likely will be supporting the digital signal, and most likely even up to 400 Hertz at least, okay, frequency. Now, this controller here is only one who do not have the touch screen, but it has this joystick here which you are using to control everything, where the rest of those two, they have a touch screens, okay? So this one is best price for the colorful display radio system which you can buy pretty much in these days. Probably does the job really good, you know. You can use as well rechargeable batteries in it, so that's nice add-on. And yeah, will do the job as well. Now, next one, we have this Upsima controller here. So this Upsima radio system is actually, let's talk about the Upsima itself. So Upsima is a German company which do not make anything by themselves. So what they does, they pretty much just find the things around the world, mostly in China, most likely, you know, and then become a distributors in Europe, or rebrand the stuff, and sometimes even does some tweaks to the software so they can actually, you know, control the pricing probably in Europe market. They also actually selling lately those FlySky controllers here with customized firmware, where we have much more languages than the FlySky providing themselves. So that's that. Now, about Upsima company itself, you can trust this company because the stuff they are finding and rebranding is fairly good stuff. So I'm using also the Shorty high voltage lipos for my RC cars, and they are good. They does the job, you know, I can't complain, and reasonably priced as well, I would say, you know. So yeah, original maker for this radio system is the W Fly company. So they have model which is X9. This specific is Upsima CR9T. So their naming always as well is quite similar to original ones. And then the last one, we have another FlySky radio system. This is NB4 Plus. So this would be, you know, the most expensive controller here. It's also only one which is made with aluminium body, but it comes with one big downside. So this is the most heaviest radio out there. So if you are, you know, using that controller in your hands for many hours, you definitely probably will feel that. That is why I like this one, because it's so super lightweight comparing with the rest of them. So that's about the radio system. So now you know that when you are picking the radio system, if you will be going for a digital setup for your steering, then one of those three will be one of the best options you can probably get, where this one will support only analog system, okay? So it does not make sense you to buy a digital servo and then expensive kind of gyro if you still will be using only analog radio system, okay? So, knowing that now, what we will be doing, we will be now testing this servo which I have here, which I was testing in my last video. And currently it's connected with FlySky NB4 Plus radio receiver. I'm not using any gyro anything, because now I want to demonstrate and show you how it will actually perform when I will start changing the frequency now on the radio system itself. And we will also take a look on other different servos here. We will try out and see how they are performing under same conditions, okay? So now let me just put the camera on a stand and I will demonstrate you how this all works. Okay, so now I have my servo in, which I had issues with OMG version 3 and Yokomo version 4 gyros, that they was pushing out to its 330 Hertz, and that's where we are specifically was having an issues. Now, let's go back in main menu. So FlySky Noble NB4 Plus is now connected. So where I can find the frequency for the servo is going into the settings, RX set, and then we have servo frequency. So there we will find three options. Sorry for reflections. So first one will be analog servo, Then we have digital servo, and then last option is the custom, where we can customize the frequency ourselves, okay? Now it can go up to 400 Hz, which is over 333, which is normally in digital mode these days. So now in analog mode, you can see the steering is working perfectly fine, no issues. If I will now switch to digital servo, so now we are in 333 Hz, the same as Yokomo version 3 and OMG version 3 and Yokomo version 4 was pushing out, and you are straight away noticing that we are having same issues that we have with those two specific gyros. So you see that this specific servo cannot handle those 333 Hz. I did as well some testing playing with the frequency myself. So if I will now go to manually set 140 Hz frequency, my servo is still working perfectly fine. But if you will remember that this specific servo can handle up to 240 Hz, and once I start increasing that to 240 Hz, so now I'm at 240 Hz. You see, even in 240 Hz we're still having issues. So now my question is this specific servo has some issues, or they are lying in the spec about the frequency, how much it can handle? Because when I'm going down, I notice that 140 is actually that maximum where it works just fine. And when I'm going to, for example, 150, so let me put 150 Hz, sometimes it works, but sometimes I was noticing that even at 150 it was experiencing problems, okay? So that's there. That's how it's kind of working. So this is a proof that our theory about the frequencies is correct. So this specific gyro can hold up to 140 Hz, and everything over that one already, not the gyro but the servo, has issues, okay? Now we are done testing with that one. Now we know for sure that it's not gonna work. So I have two more servos here we can try out. So this one is also Servos. The difference here is that this as well is stated as 240 Hz servo, same as that one which we have inside. Two main factors. So this is very low profile, as you can see, comparing with Rev D. It's even smaller than the Rev D in the footprint. This has a coreless motor inside for the servo, where this Rev D RSST has a newer version, now Pro version, which also has this coreless system inside for the motor. What this coreless helps with is actually speed. So this small Servos servo has almost twice as much speed as it is for this specific servo here, and includes as well this Rev D. So this Rev D actually is quite slow servo. Again, information is not provided how quick it actually is, where I found somewhere online information where it was talking about speed. It was just saying that it's variable because we can control this speed, but I do believe it's not gonna be any quicker than this digital servo here, okay, where it's coming to speed. But this one is very high speed servo. Do we really need in a drift car very high speed servo? Probably no. Where the speed is important is probably on a small technical tracks, where we need to turn our steering fairly quickly. On a bigger, larger tracks, that's probably not the case, and that is why the RSST original one works just fine. But as you can see in the latest now Rev D RSST Pro, they as well using this coreless kind of system in their servos. So they are definitely going after the speed, because some people were complaining that Rev D RSST was feeling a little bit slow. Now, this is 240 Hz servo, twice the price as that one. Will it be able to handle 333 Hz? That's what we will try out now. I will add it in and we will test it out. And then we will finish with Rev D RSST, okay? Okay, so now Servos SC1252MG is in cordless servo. I'm in analog mode. You can see the steering is working perfectly fine, of course, in analog mode. It is buzzing, which for digital servos it is kind of normally that they have some sort of sound coming out. The sound is coming from it tries to hold that position where it is, okay? So that's where the buzz is coming. If it's too noticeable, too loud, then of course it's not good, and you always need to watch after temperatures. If you feel that the servo is heating up a lot, then it's not good, of course, okay? Now let's go to fully digital mode, so 333 Hz now. And you can see that the steering is working perfectly fine, and even this was kind of stated as well at 240 Hz rate. Like I said, if it's not mistake, this servo is kind of dealing with 333 Hz just fine. No issues, and yeah, only thing I would probably now start looking after, if there is no mistake in the manual, that temperatures. If it will be heating up too much, of course, eventually it probably will burn out and die. But yeah, apart from that, as you can see, this rated at the same rate, but twice the price, with all the metal gearing inside and cordless motor, works at 333 Hz just fine. Okay, and now with RevD RSSD installed, analog mode, of course it will be working just fine. No issues with that. And if I will switch to digital mode, of course as well it should be working without any issues. And as you can see, it's all fine. So what I'm noticing right away comparing with other two Servos digital servos is how much slower it is in the first place. And the second thing is that maybe it's a tune in this specific servo already, but how smoothly it is returning back. It's almost like partially assist mode, which is slowing down your, and smoothing out your servo activity. So that definitely will play a big difference how it feels when we are driving. So after this video, what I will be doing, so we will do now all 4 gyro tests with this specific servo here. But I also want to try out and test this high-speed Servos servo and see how this actually performs when it's coming to driftability, comparing with this RevD servo here. Okay, so now just recap what we learned today. If you are after analog setup, then only one thing you need to really pay attention to is the gyro, because you can see that some gyros cannot really fall back and send out the analog signal from them. And that's only one device which you can really go wrong with if you are after analog setup. Everything else still will be falling back to analog setup and everything will be working fine, okay? Now, if you are after digital signal, that's of course different story. Then you need to make sure that all 3 components we look today, that they are actually able to support digital signal and higher frequencies, because digital signal is not only as well about the higher frequency, it's actual hardware difference inside devices where the microprocessors are involved, which now can deliver those higher frequencies, okay? So in the next video, I still will be testing out all 4 gyros, this time with RevD RSSD servo. So I know for sure now that they all 4 will be working, and now we will see which gyro is best of the best, or if there will be any difference at all, So that's gonna be in the next one about today's educational video. I do believe that this information was really needed out there because nobody is really talking about this, and as you can see, it's very important, okay? So feel free to share this video with your RC communities, with your friends who are coming in this hobby, because I do believe it will help them a lot, especially where they making a decisions what electronic components they need to buy. And in the long term, this as well probably will help to save a lot of people, money, so they buy what they actually need. So keep this video as well probably saved in a playlist which is watch later or something like that, so you can always come back before you are doing any purchases, because knowing those digits, what was important, sometimes can be a little bit tricky if you are not working with this, you know, on a daily basis. So from here, if you still have any questions or if you have something to add to this video, feel free to comment that down below. If you liked today's video, don't forget to hit that like. If you want to see more from me, consider to subscribe, and I will see you on the next one. Ciao.